Verifying identities can be one of the things that students struggle with in this class more than others. That is because there is no one way to prove these identities. There is actually a lot of different ways. There's also a lot of different ways that don't work. So I would like to highlight some things here. First off, verifying trig identities requires a healthy mix of tenacity and inspiration. You will need to spend some time struggling to become proficient. Verifying identities takes practice. There is no shortcut here. However, there are some tips and tricks we can use to help us along the way. These are our listed strategies. Now, like I said, it's not like every single one of these will work every time. You kind of got to get used to practicing with these and figuring out what you should do to get to where you need to go. So here's your tips and tricks. Number 1, work on the more complicated side of the identity first. That's the first thing you're going to do, is pick the complicated side, and you're going to try to simplify the more complicated side to look like the other side. Second, use the reciprocal and quotient identities to write the function on one side in terms of the other side. So if one side is in tangents and secants and the other side is in sines and cosines, change the tangents and secants into sines and cosines using the reciprocal and quotient identities. Next, add rational expressions by obtaining common denominators. We're going to do that a lot this lesson, finding those common denominators. Fourth, here we go. Use those Pythagorean identities that we just came up with. Basically, anytime you see something squared in a problem, you're probably going to use one of those Pythagorean identities we just came up with. That also includes simplifying sum and difference of squares to come up with the Pythagorean identity. So what I mean by that is if you take 1 minus sine of theta and you times it by 1 plus sine of theta, if you FOIL all that together, distribute it, you would get 1 minus sine squared of theta, which is now our Pythagorean identity we can change into cosine squared. So using those sum and difference of squares to get your Pythagorean identities is a really powerful tool. Next, multiply the numerator and denominator by the conjugate to give you a Pythagorean identity. And we'll see a problem that uses that today. Next, if you find yourself stuck, change to the other side. But please keep in mind, you cannot move things from one side to the other. This is not an equation. I can't add one to one side and add one to the other side. I can't move the cosecant over to the other side. I can't move things from one side to the other. You can only work on one side at a time. Usually pick the more complicated side and simplify it, but if you get stuck there, move to the other side and try to work from there. But you cannot move things from one side to the other. Now, keeping all those tips and tricks in mind, here's some things that I personally do to help me with these problems. First off, anytime I need to verify or prove an identity, I put a big bar down the middle. That bar helps me remember I cannot move anything across that bar. What's on one side has to stay on that side. Next, pick the more complicated side to work on first. This one definitely looks more complicated, so we're going to look at the left-hand side on this one. I need to simplify this left-hand side to make it look like the right-hand side. Now, this one might seem pretty easy and pretty obvious with your reciprocal identities. We know that 1 over cosecant of theta is sine of theta. Now, you know that you're done with your verified trig identity as soon as you can get one side to equal the other side. So as soon as I have one side equals the other side, I put a check mark, proving, hey, look, I changed one side to make it look like this side. I'm done. If you do not have this line here, where this equals this with your check mark, I will take away points. This is the final line that you need in every single trig identity. Now, one other thing that we should note is what we used to get from this first line to this second line. The thing that let us change 1 over cosecant to sine was the reciprocal identities. So anytime I use one of my identities, I should list off to the side what identity I'm using to change how something looks. So that was a pretty simple one. All we needed was one step. Let's take a look at one that's a little more complicated. First off, put your line down the middle so you know that you cannot cross it. Second, pick the more complicated side to start on. I'm going to pick the right-hand side here because this one seems like the more complicated side to me. This is the side I can change stuff on. So, sine of theta, I'm going to leave alone. Secant of theta, however, I can change to 1 over cosine of theta using my reciprocal identities. So notice I'm only working on one side. I made a change here using my identity, so I noted which identity I'm using. Now I can use some algebra. This is just multiplying across. So the sine times 1 gives me sine of theta. 1 times cosine gives me cosine theta. Now, if you stop here, you will lose points. You're not done. You haven't shown that this side equals this side. They're not exactly the same thing yet. So you need to take that one last step and say, well, I know that sine over cosine is tangent of theta, and I know that because of the quotient identities. The quotient identities tell me I can change this into this. Now the left-hand side equals the right-hand side. I can put my check mark. I am officially done. I changed one side to make it look like the other side, and I noted what identities I used to do that. So that is the basics of trig identities. Let's go to the next page and try another one, a little harder this time. Now remember, always start with your bar, so you remember you cannot move things from one side to the other. I would like you to try this one. I'm going to give you a hint how to start it, and then I want you to go from here. Notice this is a difference of squares. So use this difference of squares and start by foiling or distributing these together and see what you get from there. See if maybe you can use a Pythagorean identity that we started this lesson with to change it into one. So pause the video, try this out on your own, and then come back to check your work. Let's see how you did. I distributed these together and I got this. I noticed that my middle two canceled out and I ended with secant squared minus tangent squared, which is one of our Pythagorean identities. So I noted I am using a Pythagorean identity to change this into 1. And now I have the left side equals the right side with my check mark. I am officially done. So notice I started with the more complicated side. I simplified it, noted my identities when I used them, ended with left side equals right hand side check mark. If you ended right here, you would lose points. That's not the full thing. You need to take it all the way to where one side fully equals the other side. One other note on this. Please remember to not get lazy with your thetas. If you just start writing secant squared minus tangent squared and you leave these thetas off, I will mark you down points. You have to have the theta, the angle, the variable attached to your trig function or it's not complete. So don't get lazy and start dropping thetas. Be careful you leave those in. Now, that is all we're going to do for this video. In the next video, we'll continue practice verifying these trig identities.